Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session, we have completed the system of particles and center of mass, lecture number 4, where we discussed about the collisions concept. Alright, so basically we discussed the elastic collisions part. So where the momentum will be conserved and the complete energy will be conserved, right? So the initial kinetic energy will be equals to the final kinetic energy. So they are the elastic collisions. So today's session, so first we'll discuss about the elastic collisions in 2D. So till now whatever the elastic collisions we discussed, so that's simply in 1D, one dimensional motion. So now elastic collisions in 2D. So what does it mean by 2D, sir? So if one body is moving and another body is at rest, or it is also moving, let's suppose. So now after collision, let's suppose one body is going this side and another body is going this side. So till now whatever the concepts that we discussed, either two bodies are moving in the right side direction, or one is right side, one is left side. So that's a 1D. But after collision, if they move like this, so one is this side and one other is this side. Okay, so then such collisions are said to be the elastic collisions in 2D. Okay, so that concept we'll discuss first, then we'll go for the inelastic collisions. So what's the difference between elastic collisions and inelastic collisions, and how do we solve the questions related to inelastic collision? And then we'll also discuss about the coefficient of restitution. Okay, and at the end of the session we'll also see the rebounding concept. So what will be the velocity, to what height, so the rebounding takes place. So all these things we'll discuss in detail in today's session. So as usual, I just need your attention for the next 1 hour, guys. So just be with me, avoid all the disturbances around you. So if you have started the lecture, so just finish it off in one stretch. So don't listen for first 30 minutes and again going somewhere and again coming back and doing next half an hour. So that will not work. So I suggest you to complete the lecture at just one stretch, so that you can write your own short notes at the end of the lecture. So spend 10 more times after the lecture, so 10 more minutes after the lecture, so and write all the formulas which are involved in today's concept. Clear? So that's it, guys. So chalo, so let's get into the topic without wasting much time. So first let's see, these are the question I gave in I gave homework for the last class, right? So 2 questions I gave homework. So let's solve those questions. Hope you guys solved, but I did not receive any comments related to that. So again I am solving. So let's see. So the first question: a ball is moving with its velocity 2 meters per second towards a heavy wall moving towards a ball with speed 1 meter per second as shown in the figure. Assuming the collision to be elastic. See, hint. So assuming the collision to be elastic, so then find the velocity of the ball immediately after the collision. See, understand the concept. So actually this concept, so we have some shortcut, but in that shortcut, so where the wall has to be rest, one is of the small body, the m2 is far greater than m1 and u2 is equals to 0. So then we have the shortcut. So directly you can tell the answer. But in this case, the wall is not at rest. So here, wall is not at rest. Wall is not at rest. So wall is also moving. Okay, so clear? So first, we need after collision, what is the velocity of the ball? So that means let its velocity after collision be v1. So what's the v1 formula? So the v1 is equals to, so we can write m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2 So clear this part? This formula we already know. So just simply substituting the values. So the v1 is equals to, so what is the C? As the wall mass is far greater than the ball mass, right? So as m2 is far greater than m1, we can consider m1 is almost negligible, right? m1 is almost tends to 0. So if m1 is 0, so I can write minus m2 by, so this is also m2 into, so what is the u1? u1 velocity is 2 meter per second. So plus, so here 2 into m2, so m2 let it be, and m1 0, right? So and m2 only. So into u2. So u2, shall I take it as -1 because the wall is moving with a speed of -1, right? Initial. So from here the v1 velocity will be equals to m2 gets cancelled. So this is -2. So here m2 gets cancelled. So -2. So total it's going to be -4 meter per second. So what is this minus indicates? So we considered the right side direction as positive, right? So that's why I have taken this u1 as 2 meter per second positive and this u2 as -1 meter per second negative. Okay, understanding? So this side direction is positive. So we got the ball velocity is 4 meter per second to the left. After collision, the ball will move with a velocity of 4 meter per second. So to the left, just consider the magnitude so that we get the answer 4. Option 4 and answer is also 4 meter per second. Clear guys? The simple question, right? Chalo. So let's go for the next question guys. So the question number 2. So this also I gave it as a homework for the last session. So let's solve this one. A proton of mass mp collides with a heavy particle which is at rest. So there is a proton of mass mp. So it collides with a heavy particle which is at rest. Fine. So after collision, proton bounces back with 4/9 times of its kinetic energy. Let's suppose its velocity u initially or u1. So however u2 is 0 because it is at rest. So now after collision, so it bounces back. So the proton bounces back, let's suppose with velocity v1. So then 4/9 times of its initial kinetic energy. What does that mean? So its final kinetic energy is equals to 4/9 times of the initial kinetic energy. So they are talking about the proton. The proton's final kinetic energy is 4/9 times of its initial kinetic energy. Okay, so the collision is perfectly elastic. So find the mass of the heavier particle. We have to find its mass. So first let's find what is the velocity of the proton after the collision. So how do we calculate? So we know this hint. So the final kinetic energy is equals to 4/9 times of the initial kinetic energy. So what is the initial kinetic energy of the proton? So the proton has the initial kinetic energy half into its mass is mp, its velocity is u1. So u1 square. So what is its final kinetic energy? So which is equals to half into, so the mass of the proton into its final velocity, let it be v1. So therefore v1 square. So now substitute the values here. So half into so half into, so what is the mass of the proton into velocity of the proton? So by is equals to 4/9 into initial. So half into mass of the proton into, so u1 square, right? Chalo, fine. So then half cancel, mp also cancel. So from here, so the v1 square is equals to, so 4/9 times the u1 square. So from here the v1 is equals to, so square root of 4/9 times u1 square. So which is nothing but, so the square root of u1 4 is 2 by 3. So u1 is u1, right? So here we get, so the final velocity of the ball after collision is equals to 2/3 times the u1. But what we need to find the mass of the heavy particle. So now I know its velocity. We know the formula for velocity, right? So what's the formula for velocity? So we have got v1 is equals to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. So however the second particle is at rest, so its complete velocity will be equals to 0. And we got v1, the velocity of the proton after the collision, we got v1. So what is that value we got? 2/3 times u1. 2/3 times u1. So in the question they said, so it bounces back. So that means it's in the backward direction. After collision, it bounces backward direction. So that's why in place of v1, I am writing minus 2u1 by 3. Okay, is equals to mass of the first particle is mass of the proton. Second particle mass, let it be capital M. So we already considered it as capital M by, so the mass of the proton is mp and mass of the heavier particle is capital M, and u1 is, let it be u1 itself, right? So now let's do the calculations. So cross multiply guys. So here we get 2 times mp minus 2 times m is equals to 3 times mp minus 3 times capital M. So bring small m's to one side and capital M's to one side. So here if you send it to that side, so the 5 mp is equals to, so we get bring this to this side, so minus 2m plus 3m, so which is m. So that means the capital M is equals to 5 times the mass of the proton, so which is 5 times the mass of the proton. Option 1 is the correct one guys. Clear? Understood everyone? Chalo, so let's move for the next one. So the next sorry, just a minute. Yeah, just a minute guys, some extra slide has come. So it's not it's equals to, so the mass of the proton is equals to 5 times the, sorry, mass of the heavier particle is equals to 5 times the mass of the proton. Clear? So just some technical issue, so no problem. So you understood the question, right? Clear? Chal, fine. So this is done. So now let's go for, so the elastic collisions in 2D. So the elastic collision in 2D. See here, first consider, so this is a m1 mass, so which is moving with velocity u1. So an m2 mass, so which is moving with some velocity u2. Okay. So here also we are talking about elastic collision only. The collision that we are talking about is the elastic collision still. Okay. So after collision, so let's suppose, so the m1 particle is moving with some velocity v1 and m2 particle is moving with some velocity v2 this side. So that means, so their original line is this one. So this is they should collide like this. This is a original line of impact, right? But after collision they are moving this way. Yes or no? Understanding? So let's suppose I am taking this angle as alpha, consider this angle as beta. So as it is the elastic collision, the first thing, as it is elastic collision, so two things we already know related to elastic collision. So the first one is, so the momentum gets conserved, the momentum conserved, right? So that means the initial momentum must be equals to the final momentum. So the initial momentum must be equals to, so the final momentum. The initial momentum must be equals to the final momentum. So but here the momentum will be there in the x direction and y direction after the collision. Initially the momentum is there only in the x direction, because particle m1 is moving with u1 velocity in the x direction. Particle m2 is moving with velocity u2 in the x direction. But after collision, m1 is moving in some two-dimensional. So its momentum is going to be m1 v1 is its momentum, and the second particle's momentum will be m2 v2. So it is neither in x nor in y. So it will have two momentums, right? Understanding? So that's why what I am doing is, let's consider, so the initial momentum in the x direction must be equals to the final momentum in the x direction. Yes or no? So now here we get initial momentum in the x direction. So what is the initial momentum in the x direction? m1 u1 plus m2 u2. So both are in x direction is equals to, so final momentum. So can we write the components of this momentum? So here the m1 v1 has two components, one component this side and one component this side. So we get, so this is alpha, this angle is alpha, so we get m1 v1 cos alpha this side, and then this is m1 v1 sin alpha. This part is clear? Yes. Now, so similarly the m2 will have two components, one is this side, the other one is this side. So as beta is this side, we get m2 v2 cos beta is this side, and then m2 v2 sin beta will be this side. Yes or no? Understanding? Clear? Chalo. So now write the concept here. In the x direction, what's the momentum? m1 v1 cos alpha plus m2 v2 sin alpha, m2 v2 cos beta. So this is the momentum conservation in the x direction. So this is the first one. Let's write. And then similarly we can write the momentum conservation in the y direction. So the momentum conservation in the y direction, the initial momentum in the y is equals to the final momentum in the y direction. So initially both the particles are moving in the x direction only. There is no y direction velocity for the m1. There is no y direction velocity for the m2. So simply I can write, so the initial momentum in the y direction is 0 and 0 initially. But finally, so the particle m1 has the momentum in the y direction. Particle m2 has the momentum in the y direction. So m1 has m1 v1 sin alpha. M1 v1 sin alpha. So and then so this is going to be negative. Why? Downward direction. So minus m2 v2 sin beta. So m2 v2 sin beta. So from here you can write, so m1 v1 sin alpha is equals to m2 v2 sin beta. This is from the conservation of linear momentum in y direction. See the same concept. So previously, so we did the conservation of linear momentum in only one direction, right? So now in two dimensions. So x direction conservation of linear momentum and y direction conservation of linear momentum. That's it. Okay. So this is the first thing. So whenever the collision is elastic, momentum will be conserved. And the second thing I can talk about, so the second thing for the elastic collision, so the kinetic energy initial must be equals to the kinetic energy final. The kinetic energy initial must be equals to the kinetic energy final. So what is the initial kinetic energy? Half m1 u1 square plus half m2 u2 square. So after collision, so it is moving with v1 velocity. So half m1 v1 square plus half m2 v2 square. Understanding? So this is the second thing. So if it is the elastic collision, simply remember momentum will be conserved and the kinetic energy initial will be equals to kinetic energy final. So if you draw the graph of for the elastic collision in 2D, for the elastic collision in 2D, so we can simply say that the momentum will be conserved. So if you write the momentum versus time graph, so it's going to be conserved. And if you draw the kinetic energy versus time graph, so it also will be conserved. Let's suppose initial kinetic energy and this is the final kinetic energy. So will be same, but in between it can decrease. Right? Understood, guys? Clear? Chalo. So this is about the elastic collision in 2D. So let's solve the question so that you will get the complete idea. So we have got the question number 3. See here. So keeping the principle of conservation of momentum in mind, which of the following collision diagram is not correct? See here. So m1 particle, it is moving in x direction. m2 particle, it is moving in x direction initially. So then after collision, m1 is moving with some velocity and m2 is moving with some other velocity. So m1 is moving with, let's suppose v1 velocity, m2 is moving with v2 velocity. So then I can say that m1's momentum in the y direction and m2 momentum in the y direction, they both will be cancelled. And then so initially we have no net momentum in the y direction. Initially py 0. The initial momentum in the y direction is 0 because both are moving in the x direction. Take that hint. So here also there is a possibility that so its momentum and its momentum can get cancelled. So the final can also be 0. In this case it's possible. Now check the option 2. Here also, so there is no initial momentum in the y direction. Initially there is no momentum in the y direction because it is moving in x direction and it is also moving in x direction. So after collision, so it will have the momentum in y, and after collision, so the m1 particle will have momentum in y. Yes. So finally also it can be 0 because this momentum and this momentum can be cancel each other. Possibility is there. Now check the third one. So here m1 is moving in x direction, m2 is also moving in x direction. Now after collision, m1 is moving completely vertically and m2 is moving with some angle beta. Now if you observe, so this m1 will have two components. So one is this side and the other one is this side. So and its momentum can be cancelled. So initial momentum in the y is 0 and the final momentum in the y can also be 0. Why? Because this momentum and this momentum can be cancelled. So now check the option 4. m1 is moving in the x direction, m2 is moving in the x direction. So initially in the y direction there is no momentum, right? But finally, if you observe, m2 is moving in the x direction, but m1 is moving in the y direction. There is no other momentum components is there to cancel the m1 momentum. So here the final momentum in the y direction is not equals to 0. The final momentum in the y direction is not equal to 0. There is no other component. In all the three options we have, so its y direction momentum is cancelled by this one, can be cancelled. So here it can be cancelled by this one. So here it can be cancelled by this one. But here there is no other y component which is opposing this momentum, this y direction momentum. So here initial momentum is 0 in y direction, but final momentum is not 0. So here the conservation of momentum is not applicable in this. The conservation of momentum is not applicable, right? So that's why, so which is not correct, they said. So option 4 is not correct. Clear? Understood, guys? Chalo. So let's take the next question. So what's the question says? A billiard ball moving at a speed 2 meters per second strikes an identical ball which is at rest at a glancing blow. After the collision, one ball is found to be moving at a speed of 1 meter per second at 60 degrees with the original line of motion. So the velocity of the other ball shall be, see here. So first try to understand the given question. Shall we do it here or next slide? So let's do it in the next slide. So first try to understand the given question. So there are two balls which are of mass identical. So which means, so this is of mass m and this is of mass m. So initially the second one is at rest. So if its mass is m and its mass is also m. So then after it's moving initially at 2 meters per second and it hits this one, right? Chalo. So till here it's clear. After the collision, one ball is found to be moving at a speed 1 meter per second at 60 degrees. This is not 600, this is 60 degrees, guys. So here it is 60 degrees. Fine, with the original line of motion. So the velocity of the other ball shall be, see here. So the first thing is after collision, so the one particle m is moving at a speed of 1 meter per second, 60 degrees, 1 meter per second with the original line. So this is the original line. So this angle is going to be 60 degrees. Fine. So then the other mass should move in this direction with some velocity v. So because the initial momentum in the y direction is 0. So the initial momentum in the y direction is 0. So therefore the final momentum in the y direction also should be 0. So this has momentum this side and the other ball should move with some other angle. So let this angle be theta. Yes or no? So then only it's one of its momentum component will cancel the momentum component of y. Understanding? So now simply apply the concept. So the first thing is the initial momentum in the x direction is equals to, so the final momentum in the x direction. So initially we have, so it's of mass m and its velocity is 2. And second one mass is m and it is at rest. Initially in the x direction its velocity is 0. Second one. So total initial momentum in the x direction. So now what is the final momentum in the x direction? Tell me. So this will have two components. Here the momentum, so its mass into the velocity is 1. So mass into velocity m into 1 is m. So I can write m cos 60 degrees this side and then m sin 60 degrees this side. M sin 60 degrees this side. Yes or no? So then second one is moving with a velocity of v. So that its velocity component mv cos theta will come this side and then so one of its component, so mv sin theta will come this side. Yes or no? So here mass we know, velocity we know. M into velocity is 1 into the cos 60 and then this is m into velocity 1, so into sin 60 component. So now in the x direction we required, so what is in the x direction momentum? So I can write m into cos 60 degrees plus mv cos theta plus mv cos theta. So from here you can simply write 2m is equals to, so m by 2 plus, so mv cos theta. So mass let it be m. So velocity we have to find, so cos theta from here. So then, so let's bring this to this side. So we get mv cos theta is equals to 2m minus m by 2, right? So from here we can write mv cos theta is equals to, so 2 is the LCM, so it is 4m 3m by 2. So from here m cancel, so we got v cos theta is equals to 3 by 2. So let it be the equation number 1. Just understand the procedure, guys. Okay. So then, so let's take the equation 2. So what is that? So the initial momentum in the y direction should be equals to, so the final momentum in the y direction, because the collision is elastic, right? So they said it is found to be after the collision. So consider the collision is elastic. So they did not mention. So but you can consider the collision is elastic here, right? So then initial momentum in the y direction is 0 because they both are moving in x direction. It is not at all moving. It is moving in x direction. So its momentum in y is 0. So now final momentum, tell me. Final momentum m sin 60 degrees is the momentum in y direction this side minus mv sin theta. So y minus, because it is downward. So mv sin theta. So from here I can write m sin 60 degrees is equals to mv sin theta. So from here, so let's write m cancel. So v sin theta is equals to sin 60 degrees. So which is root 3 by 2. So we have got, let it be the equation number 2. So then, so let's divide. So 2 by 1. Let's divide 2 by 1. So let's divide the equation 2 by 1. So where we get, so v sin theta by v cos theta is equals to, so we can write root 3 by 2 by root 3 by 2 by 3 by 2. So from here, so 2 cancel. So we can write, so v sin theta by v cos, here v also gets cancelled. Yes or no? So v also gets cancelled. Sin theta by cos theta is tan theta. So from here, so we can write, sorry, reverse I wrote. My bad. Sorry guys. Because v sin theta by v cos theta we are doing, right? So that's why it should be root 3 by 2 by 3 by 2. Yeah. So this is correct. So here, yes or no? Fine. Yeah. So 2 gets cancelled. So this is tan theta is equals to root 3 by, so 3. So then we can write, so root 3 into root 3. So 3 we can write as root 3 into root 3. So the tan theta is equals to 1 by root 3. So therefore theta is equals to tan inverse of 1 by root 3. So tan inverse of 1 by root 3. Clear? Understood guys? Everyone clear? So here we did correct one, right? M cos 60 degrees. 1 meter per second at an angle 60 degrees with the original line of motion. So 60 degrees with the original line of motion. So m cos 60 and this is m sin 60. So m sin 60 means root 3 by 2. Yes. Yeah. So here m cos 60 means, m cos 60 degrees means we can write m by 2. Cos 60 is 1 by 2. Yes, fine. So we got theta. So now, but what do we required? So not theta. So we required theta should be 30 degrees. So tan inverse of 1 by 3, 1 by root 3. So see here, we know the tan theta is equals to, what is this value? 30 degrees. Directly shall I write? Because tan 30 is 1 by root 3, right? Tan 60 is root 3. So we got the theta. So first to check the options. Theta 30 degrees. So it is there in option 1 and option 4. So now we have to find what is its velocity also. The velocity of the ball shall be. So what is the velocity? So you can substitute any of the equations. So let me take the equation number 1. So what is the equation number 1? We got v cos theta is equals to 3 by 2, right? V cos theta is equals to 3 by 2. So in place of theta you substitute 30. V into cos 30 degrees is equals to 3 by 2. So from here we get v into cos 30 root 3 by 2 is equals to 3 by 2. So from here 2 cancel. So then v into root 3 is equals to, so 3 I can write it as root 3 into root 3. So root 3 gets cancelled. So we get it as root 3 meter per second. So finally, so the second ball's velocity, so the velocity is root 3 meter per second and the angle is theta 30 degrees. So check this option. The second ball should move with a velocity root 3 meter per second. So I can write root 3 means 3 power 1 by 2 and at an angle 30 degrees to the original. Clear? Understood guys? Simple question. So just the procedure, you have to do the calculations faster. That's it. Once you understand the concept, then you can do it easily. Right? Clear? Chalo. This is done. So let's go for the next question. So what's the question says? There are two spheres A and B of mass m1 and m2 respectively collide. A is at rest initially and B is moving with a velocity v along x-axis. So see here, there are two masses m1 and of mass m2. So initially, so the m1 is at rest. So this is a is at rest. Okay, so where this one is moving at a speed v along the x-axis. This is moving with a speed along x-axis v. So after collision, B has a velocity v by 2 in a direction perpendicular to the original line. So B has a velocity. So this is a particle and this is a B particle. So now the B means m2 body. So it has a velocity v by 2 perpendicular to the original direction. Original direction is, this is the original direction. So this is the original direction. So the mass the mass A moves after collision in the direction. See here. So the simple logic in these questions is, initially it is at rest and it is moving only in the x direction. So the initial momentum in the y direction is equals to 0. The initial momentum in the y direction is 0. Now, so m2 is moving perpendicular to the original line. So that means there is momentum in the y direction finally, right? But it should not be there. So if it should not be there, the m1 should move in such a way that it should move with some velocity. m1 should move with a velocity, let it be v dash. So m1 should move at an angle. Let's consider this angle as, so whatever it is, alpha or theta, whatever it is, you can consider, right? So then we have to find the velocity. So opposite to that, so we have to find theta actually. So what is this theta? So they consider theta in the, so let's say theta. Fine. Now see here. So what is the theta value? Obviously it should same as that of B. So it should move as that of B. This option you can eliminate. So opposite to that of B. Opposite to that of B means, so here like this. So there is a possibility. And then theta. So tan inverse of 1 by 2 or tan inverse of minus 1 by 2. So we have to check these three options. So first thing is, the initial momentum in the x direction is equals to, so the initial moment, final momentum in the x direction. What is the initial momentum in the x direction? So m1 into 0, its momentum 0. So then m2 into its velocity, B is moving with a velocity v. So m2 into v is equals to, so final momentum. So final momentum m2 into, so it's moving with a velocity v by 2. So and then m1 will have, so m1, it will have two components. One is this side, the other one is this side. So m1 v dash cos theta this side, and then m1 v dash sin theta this side. So just take care of the calculation, guys. So this is m2 into v by 2 is the momentum of this one, right? Plus, sorry, this is y direction, right? So y direction not required, only 0. In the x direction there is no velocity for the m2. So and then m1 into, so what is its velocity in the x direction? So which is m1 v1 dash cos theta, that's it. So its momentum in the x direction is m1 v1 dash cos theta. So from here let's write, so let it be, they did not give any masses, right? So let it be the equation. So m2v is equals to m1 v1 dash cos theta. So let it be the equation number 1. So now consider the equation 2. So the final momentum in the x direction is equals to final momentum in the y direction. So initially one is at rest, another one is moving in the x direction. So that's why, so the final momentum in the x direction is 0 and the final momentum in the, sorry, my bad. So the initial momentum in the y is equals to pf in y. Yes or no? So initially, so there is no momentum in the y. The initial pi, I should write. So pi in the y direction is equals to pf in the y direction. So initially one is at rest, the other one is moving in only in the x direction. So that's why its momentum in the y direction is 0. So which is equals to, so finally, so it is moving in the y direction. So with what velocity? v2. So that's why its momentum will become m2 into v by 2. And then, So what is its momentum? m1 v1 dash sin theta. So minus m1 v1 dash sin theta. Yes, so now I can write, so m1 v1 dash sin theta is equals to same previous question type, m2 into v by 2. So let's write equation number 2. So now let's divide equation 2 by 1. So let's divide the equation 2 by 1 because we need theta, right? So here I can write m1 v1 dash sin theta by, so what is the equation 1? So m1 v1 dash by cos theta. m1 v1 dash by cos theta is equals to, this is m2 into v by 2 by, so this one m2 into v. So this is m2 into v, right? So then I can write here m1 v1 dash, m1 v1 dash cancel. So this is tan theta is equals to, so m2v by, so this is 2m2v. Yes or no? So 2 will come this side, so downward. So 2 into m2 into v. So m2v cancel. So tan theta is equals to v by 2. So from here, not v by 2, 1 by 2. V cancel, right? 1 by 2. So from here, the theta is equals to tan inverse of 1 by 2 is the correct answer. So what's the answer? You can write, so theta is equals to tan inverse of 1 by 2 with the x-axis. Option 3 is the correct one. Clear guys? Understood? Chal. So let's move further. So let's take one more question. So what's the question says? So on a frictionless surface, a block of mass m moving with a speed v collides elastically with another block of same mass m which is initially at rest. So this is a capital M mass which is moving at a speed v, collides with same mass capital M, so which is at rest. Okay, fine. So initially at rest. After the collision, the first block moves at an angle theta to its initial direction. So this is the initial direction, let's take. So the first block, this is a capital M which moves at an angle theta, so and has a speed v by 3. Let's suppose it moves with a velocity v by 3 at an angle theta to the original direction. So the second block's speed after collision. So let the second block mass again m. So it should move at an angle this way because initially its momentum in the y direction is 0. So now after the collision, so m block is moving at an angle theta so that it has some momentum in the y direction. To cancel its momentum in the y direction, so the second block also should move at some angle, yes or no? So then let this angle be alpha, I am saying. Let this angle be alpha. So then simple thing, let's suppose it is moving with velocity v dash. I guess for this question you can directly, we need only the speed, right? Let's go for the, either you can conserve the momentum or you can also write the initial kinetic energy is equals to final kinetic energy. For the previous question also you can do that. So let me do this question by the kinetic energy equal. So the initial kinetic energy is what? Initially half into its mass is capital M, first block mass, into its velocity is v square. So and then this second block initially is at rest. So now after collision, so the first block which is of mass m is moving with a velocity v by 3, right, whole square. So let's say the second mass, it is moving at a velocity v dash. So v dash square. So now we need v dash. So I can write m cancel. So from here half v square is equals to, so here it is half into, so you can cancel half also. So let's take half out from all, take it, cancel it. So then here only thing left is v square is equals to v square by 9 is left here, plus here v dash square. So I need only v dash. If you need angle theta, then you should conserve the momentum. The initial momentum in the x direction is equals to the final momentum in the x direction. Initial momentum in the y direction is equals to final momentum in the y direction. But they are asking only the velocity. So go for the simple procedure here. So I can write, so the v square, the v dash square is equals to v square minus v square by 9. V square minus v square by 9. So v dash square is equals to, here 9 is the LCM. So 9 minus 1, which is 8v square, right? So from here v dash is equals to square root of 8v square by 9, so that we get, so v dash is equals to, so v comes out, so and then 3 comes out, yes or no? So then root 8, so root 8 what we can write, is there root 8 is there, root 8 is not there, so v by 3 into, so I can write this as 2 root 2, yes or no? So I guess 2 root 2 into v by 3, so option 2 is the correct one. Clear? So 2 root 2 into v by 3. So just conserve the kinetic energy. So the initial kinetic energy is equals to final kinetic energy, because the collision is elastic. Understood, guys? We need only the velocity after the collision. This is the simplest procedure. If you conserve the momentum, first you have to find the angle theta, then again the theta you have to substitute in one of the equation. So that's a lengthy procedure again. Okay. So now, so this is all about the elastic collisions in 2D. So the elastic collisions in 2D concept clear? Everyone? Chalo. So now let's go for the inelastic collision. So after collision, both bodies stick together and move with a common velocity. So in the inelastic collision, we are talking about the perfectly inelastic collision. Perfectly inelastic collisions. After collision, both the blocks stick together and move with a common velocity. Let's suppose initially, so the M1 block is moving with U1 velocity, and then M2 block is moving with some U2 velocity. So then after collision, so they both stick together, M1 and M2, so they both stick together and they both move with the common velocity, that is V. They both move with the some common velocity V. So the momentum remains conserved throughout the motion. So in the inelastic collisions, so the momentum graph if you draw, so the momentum versus time, so the momentum will be conserved. Okay, but the kinetic energy initial will be greater than the kinetic energy final. So if you draw the kinetic energy versus time for the inelastic collisions, so the kinetic energy decreases. So the kinetic energy decreases. So if you let's write it in the next slide. Is there question? No. So let's write it in the next slide. So in inelastic collision, what happens? Let's suppose this is a mass M1 which is moving with U1 velocity and mass M2 which is moving with U2 velocity, and after collision, inelastic collision, they both stick together. M1 and M2, they both stick together and they both move with some common velocity V. Okay. So the initial momentum will be equals to the final momentum. So that means I can write M1 U1 plus M2 U2 is the initial momentum, which is equals to, so the final momentum. What is the final momentum? So their masses will be added, M1 plus M2, because they both move together with the same velocity. You can write M1 into V plus M2 into V, which is nothing but M1 plus M2 into V. So this is the momentum conservation. But so here the kinetic energy initial will be equals to, the kinetic energy initial will be greater than the kinetic energy final. So therefore, so the loss in kinetic energy takes place. So what is the loss in kinetic energy? So which is equals to the Ke initial minus the Ke final. So in the inelastic collisions, after the collision, the energy loss takes place. For example, simple thing. So if you just throw a ball, like if you just throw a ball downwards, so then it rebounds as, yes or no? So for the first rebound, so it reaches to some height. So then you left it like that, and again it went to the ground and then again rebounded. So when the second time, so its height decreases. Why? So the collision that takes place with the ground is the inelastic collision. So where some energy loss takes place. Okay. So what is the loss in kinetic energy? So it's a kinetic energy initial minus the kinetic energy final. So this is all about the inelastic collision. See, so the concept is simple. The elastic collision, the kinetic energy initial and kinetic energy final are same, and momentum will be conserved. Initial momentum and final momentum will be conserved. So whether it is in 1D or 2D, you can solve the questions related to elastic collision. But when it comes to inelastic collision, from now, so you can conserve the momentum. Whatever the concepts you applied in the elastic collision related to momentum, the same concepts you can apply it in the inelastic collisions also. The momentum will be conserved. No problem. But so the energy loss takes place in the case of inelastic collision. So the initial kinetic energy will be greater than final. So the loss in kinetic energy is equals to, so K initial minus K final. That's it. Okay, so let's solve the question so that you'll understand even better. So let's try this question, guys. There are two particles of mass m1 and m2 move with initial velocities u1 and u2 on collision. So one of the particle get excited to higher level after absorbing energy. See here. So after collision, on collision, one of the particle get excited to higher level after absorbing energy. Okay, epsilon. So if final velocities of particles be v1 and v2, so then we must have, see here. So initially this is of mass m1 which is moving with u1 velocity. This is of mass m2 which is moving with some u2 velocity. So then after collision, so they are one of them is absorbing some energy. So how much energy it is absorbing? Some epsilon is a energy absorbed. Okay, so then, so if final velocity m1 is moving with velocity v1 and m2 is moving with some velocity v2. Okay, so then shall I say that, so what is this absorbing energy means? What is this concept of absorbing energy? So it's absorbing some energy, epsilon means there is some loss in energy. Understanding? So the loss in energy, we can write it like the loss in energy is equals to, so the kinetic energy initial minus the kinetic energy final. Yes or no? So now, so what is the loss in energy they gave according to the question? Epsilon is equals to, what is the initial kinetic energy? Half m1 u1 square plus initial kinetic energy half m2 u2 square, and then final kinetic energy minus half m1 v1 square, just I am multiplying with the minus directly, so minus half m2 v2 square. So check this option, m1 u1 square plus m2 u2 square minus epsilon, so minus epsilon no is equals to m1 v, so no, so not this one, so this option is wrong. So and then check this one, half m1 u1 square plus half m2 u2 square is equals to, so this if you bring it to this side it becomes plus, but here it is given minus, so this option is also wrong. So then let's write this way, so you bring these two terms to this side, guys, half m1 u1 square plus half m2 u2 square is equals to, I can write, so half m1 v1 square plus half m2 v2 square plus epsilon. Yes, so if you bring these two terms to this side, so check this option, half m1 u1 square plus half m2 u2 square, so minus epsilon, so okay, minus epsilon is equals to, yes, so this is also possible, right? Half m1 u1 square plus half m2 u2 square, just we are checking according to the options, that's it. So minus epsilon I am bringing it to this side, so which is equals to minus half m1 v1 square plus half m2 v2 square. Yes, so I got the same as option C, check it. Yes, so here plus epsilon they wrote for this side, m1 u1 square plus, so no, so this option is wrong, here it should be minus epsilon, right? So the option 3 is the correct one, guys. Understood? Sure. So let's go for the next question. What's the question says? A moving body of mass m and velocity 3 km/h collides with a body at rest of 2m and sticks to it. So that means hint. What is the hint given? So inelastic collision. It sticks to it means inelastic collision. The simple concept, right? So now the combined mass starts to move. What will be the combined velocity? So the simple thing first. So there is a mass m, so which is moving at 3 km/h. Fine. Then collides with a body of 2m which is at rest. Initially it is at rest. Fine. So then which after collision it sticks to it. The total mass will become 3m. So or else you write this way, m and 2m, so they both stick together and then move with a velocity, combined velocity v. So what is that combined velocity? So you can simply apply, so inelastic collision, the initial momentum will be equals to the final momentum. So what is the initial momentum? M into, the options are in km/h, just take it in km/h only. So m into mass is m and velocity is 3. So here it is initially at rest, so 2m into 0. Finally, so the total mass is 3m. It moves with a velocity v. So from here, this is 0. 3m is equals to 3m into v. So 3m cancel. So v is equals to 1 kilometer per hour. So we get velocity v is equals to 1 kilometer per hour. Option 3 is the correct one, guys. Understood? Clear? Chal. Let's move further. So the 9th question. So what's the question says? A metal ball of mass 2 kg moving with a velocity 36 km per hour. So this is a ball of 2 kg which is moving with 36 km per hour. So convert it to meter per second better. So 36 into 5 by 18, which is nothing but, so 2 times. So this is 10 meter per second. Fine. So has an head-on collision with a stationary ball of mass 3 kg. So here is a 3 kg ball, so which is at rest. Initial its velocity 0. So if after the collision, 2 balls move together. Here, 2 balls move together. So that means what kind of collision it is? The collision is going to be inelastic collision. Okay, the loss in kinetic energy due to collision. So we have to find the loss in kinetic energy due to collision. First, with what velocity they move together? So 2 kg and then 3 kg, they both combine. So they move with some common velocity v. So they move with some common velocity v. So let's find that common velocity first. So how do you find that common velocity? So initial momentum should be equals to final momentum in inelastic collision. So the initial momentum is, its mass is 2 and its velocity is 10, plus the second one 3 kg is at rest, so 0 is equals to, so the total mass 5 kg mass is moving with velocity v. So here it is 20 is equals to 5v. So v is equals to 4 meter per second. So v is equals to 4 meter per second we got. Fine. But this is the final velocity. So can we find what is the initial kinetic energy? So the initial kinetic energy is equals to, so half into, so the first body mass is 2 kg. Its velocity 10. So 10 square. And then second body half into mass is 3 kg and its velocity 0. Right? Yes or no? So the 0 square. So the initial kinetic energy will be, so 100 joules. And then final kinetic energy. So why we are finding kinetic energy? Because they asked loss in kinetic energy. So I know both the initial velocities and both the masses. So I can find the initial kinetic energy. So final kinetic energy, so total mass is 5 kg into, so the final velocity we got it as 4 square, 4, which is 4 square. So half into 5 into 16. So 2 ones are 2 8s are. So 8 into 5, 40 joules. So this is the initial and this is the final. So now how do you find the loss in kinetic energy? The loss in kinetic energy will be equals to the Ke initial minus the Ke final. So which is nothing but, so 100 minus 40, which is 60 joules is the loss in kinetic energy. Yes or no? So option 2 is the correct one, guys. Understood? Simple concept. Clear? Sure. So let's go for the next question. So what's the question says? The question number 10. So here the question says, a neutron having mass 1.67 into 10 to the power minus 27 kg and at 10 to the power 8 meter per second collides with a deuteron at rest. So deuterons mean 2 times of the mass of the neutron. So at rest. So fine. And sticks to it. So if the mass of the deuteron is also given 3.34 into 10 to the power minus 24. So minus 27. So kg. So the speed of the deuteron. So after the combination, see here. So first sticks to it. So here hint is given. What kind of collision it's going to be? The inelastic collision. So here is a neutron. So let's consider this is a neutron which is moving at a speed of 10 to the power 8 meter per second. And it collides with a deuteron which is at rest. So here this is a mass of the deuteron, let it be, which is at rest. So then after collision they both move together. So that means neutron and deuteron. So they both move together with some common velocity v. So what is that common velocity v? We have to find. So the collision is inelastic. So simply I can take the initial momentum is equals to the final momentum. That's it. Inelastic collision, the conservation of momentum takes place, right? So what is the initial momentum? So mass of the neutron into its velocity. What is the mass of the neutron? 1.67 into 10 to the power minus 27 is its mass into, so its velocity 10 to the power 8. It's moving with 10 to the power 8. So and second one is at rest, so its initial momentum is 0. And finally, so they both combined, so the mass of the neutron plus the mass of the deuteron combine into, so they both together move with some common velocity v. Understanding? So now let's substitute the values. Here it is 1.67 into 10 to the power minus 27 into 10 to the power 8 is equals to mass of the neutron is 1.67 into 10 to the power minus 27, and then mass of the deuteron is what, 3.34 into 10 to the power minus 27. So into, so common velocity v, right? So from here you can take 10 to the power minus 27 common from these two, so you can cancel it, 10 to the power minus 27. So here 1.67 into 10 to the power 8, so which is equals to 3.34 plus 1.67. So we can write approximately 5.01 into, so the velocity v. So now we need the velocity. V is equals to 1.67 by 5.01 into 10 to the power 8. So now let's consider the denominator is 5. So if it is 5 ones are, so it is 0 times, so 3, and then 1 and 7, so again 3, so 205, so which is nothing but 0.335 into 10 to the power 8. So check the options, 0.335 into 10 to the power 8. So I can write 3.33 into 10 to the power 7. Yes or no? So I have got this option, the closest option. So 3.33 into 10 to the power 7. Clear guys? Understood the concept? Chal. So let's move further. So what's the next question says? Try to understand the given question first. A particle of mass m moving eastward. So let's consider this is a east direction. So west, north, south. So consider the reference. So m mass is moving east with a speed v, collides with another particle of the same mass. So another particle of the same mass, so which is moving northwards, so with the same speed. So it is moving northwards with the same speed v. So then the two particle coalesce means, so the two particles combine after the collision. So the two particle combine after the collision means what kind of collision it's going to be? The elastic collision. The collision is going to be the elastic collision. So here m and m, so they both combine and move with some common velocity, let it be v dash. Already here v is given, let's say. So the new particle of mass 2m will move in the northeast direction. So in which direction it is moving? See here. Here the northeast direction. So let's suppose its velocity is v dash. So then with what velocity it will move? So that v dash velocity we have to find. So the first thing is, so what is here, the collision is inelastic, but the inelastic collision in 2D. It is the, see, however, how do we did the questions related to the elastic collision in 2D? Same concept you can apply. So the conservation of momentum you can do. See, so I can say that the initial momentum in the x direction is equals to, so the final momentum in the x direction. Yes or no? So let's suppose it is moving at an angle theta with the original. Let's suppose at an angle theta with the original. So what I can write is simply, you can't equate the kinetic energies guys. So don't say that the kinetic energy initial is equals to kinetic energy final, because it is a inelastic collision. So don't do that concept. So first you have to find its velocity, then only velocity required, right? You have to find its velocity just by using the conservation of linear momentum. That's it. Okay. So the initial momentum in the x direction. So the first particle is moving in the x direction, m into velocity v. Yes or no? So and then this is 0. The second particle is not moving in the x direction, it's completely moving in the y direction. So north direction, right? So y. So which is equals to finally, so this 2m mass is moving with some velocity v dash. So it has two components. So one is its velocity 2m v dash into cos theta, and then so in the y direction 2m v dash sin theta. Yes or no? Now, so in the x direction I can write 2m v dash cos theta. So let it be from here. So the mv is equals to 2m v dash cos theta. From here m cancel. So we got v cos theta is equals to v. So this is a momentum in the y direction. So v cos theta or 2v dash cos theta. 2v dash cos theta is equals to v. Let it be equation number 1. Similarly, so do the conservation of momentum in the y direction. The initial momentum in the y must be equals to, so the final momentum in the y. So initially there is no y direction momentum for this because it's moving in the x direction. So but the second particle is moving in the y direction. So that's why mass into its velocity is the initial momentum in the y direction. So plus this one 0 is equals to, finally, so what is the momentum? So 2m into v dash into sine theta. So the final momentum after combination, right? So then see here, mv is equals to 2m v dash sine theta. From here I can cancel m and m. So here 2v dash sine theta is equals to v. Yes or no? So 2v dash sine theta is equals to v. So now let's do one thing. So let's divide equation 2 by equation 1. So let's divide the equation 2 by 1. So we have got 2v dash sine theta by 2v dash cos theta is equals to, so v by v. Yes or no? So v by v, they both are moving in the same speed, right? Yes, v cancel, 2v dash cancel. So that means tan theta is equals to 1, right? So which is nothing but theta is equals to 45 degrees. But we do not require theta. We required what? So we required the v dash velocity we required. So this cos 45 degrees, you substitute it in either equation 1 or equation 2. So let's substitute. So theta is equals to 45 degrees. So let's substitute it in equation 1. Substitute in equation number 1. So what's the equation 1, guys? 2v dash cos theta is equals to v. 2v dash cos theta is equals to v. From here 2 into, so v dash we have to find, cos theta what did we get? So 45 degrees. So v is v only. So from here, so 2v dash into 1 by root 2 is equals to, cos 45 is 1 by root 2 is equals to v. So from here, so you can write v dash, so here 2 I can write it as root 2 into root 2 by root 2. Yes or no? 2 I am writing it in terms of root 2 and root 2. So is equals to v. So here 1 root 2 gets cancelled. So finally v dash is equals to v by root 2. So v dash is equals to v by root 2. So that's what we have to find. So they said what is the velocity of the combination, which is v dash v by root 2. Yes or no? We got the same, v by root 2. So option C is the third one is the correct answer, guys. Clear? Understood the concept? Chalo. Let's move further. Chalo. So let's go for the next question, guys. So what's the question says? A mass m moving horizontally along the x-axis with velocity v collides and sticks to a mass. Sticks to a mass means hint is given here. So what's the collision type? So it's an inelastic collision, right? And then, so sticks to a mass of 3m moving vertically upward along the y-axis with 2v. See here, the first mass, small m, is moving with a velocity v along the x-axis. So the second mass, which is moving 3m, which is moving at a velocity 2v, right? So the final velocity of the combination, so they both sticks together means, so 4m mass, so we'll move with some other velocity v dash. Yes or no? So then it will have the velocity in the x direction. So let it be. So it moves some velocity u. So then it will have some x direction velocity and it will have some y direction velocity. So as the collision is inelastic, so whether it's elastic or inelastic, you can apply the conservation of linear momentum, right? So here the conservation of momentum in the x direction is equals to, so the p final in the x direction, right? So here in the x direction, the first one, m into v is equals to, however, its momentum in the x direction is 0. So finally, so the 4m mass, so let its velocity in the x direction is ux, right? So here we get mass cancel. So we get ux is equals to v by 4. So that means we got this velocity as v by 4. Fine. So then next, let's write the final momentum. So the p initial in the y direction is equals to P final in the y direction. Yes or no? So now initially y direction, so it's moving in the x direction, there is no momentum in the y. So it's moving in the y direction, so 3m into its velocity is 2v is equals to finally here 4m mass, it is moving in the y direction with a velocity, let's suppose uy. So from here we got, so m cancel, 2 1s are 2 2s are, so uy is equals to 3 by 2 v. So this is a v. So that means this velocity is 3 by 2 v. Understood? So now total u vector you can write it as, so v by 4 I cap plus, so 3 by 2 v j cap. V by 4 I cap, so 3 by 2 v j cap. So because they asked it in the vector form. So x direction, the total velocity u, actually you can write it this way, so to simply understand. So the final vector u will be ux I cap plus uy j cap, right? So from here you can write ux means v by 4 I cap plus uy means 3 by 2 j cap, 3 by 2 v j cap. Okay, so this is a final answer. Clear guys? Understood? Sure. So let's move further. So let's take the next question. What's the question says? A bullet of mass m moving with velocity v strikes a suspended wooden block of mass m as shown in the figure and sticks to it. So that means the inelastic collision happened between these two. Here m mass bullet, it is moving with velocity v and it sticks to the, after collision it sticks to this one. Okay now, so then if the block raises to a height h, the initial velocity of the bullet is, yes, very good question. So here these are the standard types of questions. So let's understand. So here two concepts you have to apply. The first one, the first concept is, so inelastic collision concept. The inelastic collision concept. So between these two blocks. So between the bullet and the wooden block of mass capital M. So this is a bullet of mass small m, so which is moving with velocity v. So initially this is at rest, the capital M which is initially at rest, right? So now after collision what happened? So the bullet and wooden block, so they both move together, so with a common velocity v. Yes or no? As it is the inelastic collision, so shall I apply? So the initial momentum is equals to the final momentum, the conservation of linear momentum we can write. So initially its velocity, let's suppose they move with some common velocity v dash. So then m into, so its bullet velocity is v, mass into its velocity is v, is equals to, so they both move together. So that means their combined mass will become m into m plus m. Yes or no? This is small m, this is capital M. So they both combinedly move with a velocity v dash. So let it be v dash. So from here we got, so the v dash velocity, so is equals to mv by m plus m. Yes, so the first concept is clear guys. So till here this is the first concept. Between these two you apply the first concept. Now from here to here the second. So once the bullet hits the block, so what happens? The block raised to some height h. The block has raised to some height h. So we have to find what is this height. So the thing is, here shall we apply the conservation of energy? Yes, the conservation of energy can we apply between these two. So in the second scenario I am applying the conservation of energy. So from here to here, so I am applying the conservation of energy. Alright, so let's write the second thing. So the initial kinetic energy plus, so initial potential energy is equals to final kinetic energy plus final potential energy. So initially consider this is the ground. Consider this is the ground. So initially the wooden block is on the ground. Yes or no? So therefore its initial potential energy is 0. What is its initial kinetic energy? So half into the total mass. So here they both combined. What is the total mass of them? M plus m into what is their velocity? What is their velocity we got? So the velocity of this one is now v dash, block and bullet. So they both move together after the collision, right? So what's the combination velocity? So which we got it as mv by m plus m, not v dash, mv by m plus m, right? So whole square plus, so this is the initial kinetic energy plus initial potential energy is equals to, what is the final kinetic energy? So after raising to some height, so its velocity will become 0, so its final kinetic energy is 0. And what is the final potential energy? It raised to a height of h from the ground, so mass, what is the total mass? M plus m into, so gh is a height, yes or no, mgh. So what is the total mass of this block? So bullet mass plus the wooden suspended block mass, so capital M plus small m, yes or no? So now see here, just apply the concept. So I can write, so here 1 and 1 gets cancelled, so I can write half into, so in the numerator half, m square v square will be there if we multiply, so then here m plus m into gh. So what do we require actually? To what height it raises, right? So if the block is height h, so then initial velocity of the bullet, means v we have to find, yes or no? So the initial velocity of the bullet means v we have to find. So how do we find v from here? So the v square, half mv square is equals to m plus m into gh by 2m square. Yes, so from here, so what is v? So let's check the options once. So it is in terms of root 2 gh and like that. So let's write this way. So we can write, sorry, 2 if it goes that side multiplies, right? So here I can write m plus m, let's write m square also to this side, m square is equals to, so 2gh, fine. So then v square is equals to, we can write, so m plus m into root 2gh by m square. So from here the v will be equals to root of, so some calculation mistake guys, so check it where the calculation mistake went. Initial kinetic energy, initial potential energy 0, half into mass of the bullet plus mass of the gun, m plus m, into the velocity. What is the velocity? We got mv by m plus m, mv by m plus m whole square is equals to 0 plus m plus m into gh, fine. Sorry, here I did the calculation mistake, sorry guys, my bad. So here only one m plus m gets cancelled, right? One more m plus m will be there. So here half into, sorry, here m square v square by, so here one more m plus m will be there, na? Very sorry, so I did not check this one. So is equals to m plus m into gh, right? So now, so I can write here, so send this 2 and m plus m to that side, so we can write m square v square is equals to, here it is m plus m into m plus m, so which is m plus m whole square, and 2 also if you send it to that side, so 2gh. So you send we need v, right? So v square is equals to m plus m whole square by m square into 2gh. So from here v is equals to, so m plus 1 whole square is m plus m, m square whole root is m into root 2gh. So check for this option, v is equals to m plus m by, so what is this one? Capital M, right? So this is small m, sorry, m plus m by small m, yeah. So m plus m, so check the options properly, small m plus capital M, small m plus capital M by small m, small m plus capital M by small m into root 2gh. I could see the option 1 itself, small m plus capital M by small m into root 2gh. Option A is the correct answer. Clear guys? Understood the concept everyone? Chalo. So let's move further. See, this is a standard question. So in the same question, if they ask to what height it will be raised, so in the same question, previous question only, so to what height, find h, simply right, find height h. So we already studied, right? So the h is equals to v square by 2g. In the last class I have explained. So you know the v value now. What is the v? So this is the v. So this whole square by, so or else you can write from here. So the h is equals to this whole thing by 2g. Yes or no? So from here you can get the velocity. Here also, see, from the same thing you can write what is h, or else you can directly remember the formula h is equals to v square by 2g. You can find velocity from this formula and then substitute it here so that you will get the height. Okay, so we'll solve one question so that you will understand even better. So let's go for the next question. See guys, what's the question says here? A mass of 10 grams moving horizontally with a velocity 100 meter per second strikes a pendulum bob of mass 10 grams. So there is a 10 grams moving horizontally with a velocity 100 centimeter per second. Take care of the take care of the unit conversions. So pendulum of bob 10 grams. So here is a pendulum. So where a bob of mass 10 grams is hanging. So the length of the string is 50 centimeters. Fine. So the two masses stick together. So after it colliding with this, so those two masses stick together. So that means here the collision that takes place is an inelastic collision first. Okay. And then, so the maximum height reached by the system now is. So the maximum height reached by the system. So the same thing. So once it raises to some height h. So those two blocks, 20 grams block now raises to some height h. So to find height h, we have the formula h is equals to v square by 2g. So now you need not to remember the previous formulas also. This formula, velocity formula, you need not to mug up. Just apply the procedure. If you remember, you can directly substitute. But if you don't remember, just directly go for the procedure. Between these two, apply the conservation of linear momentum. So if you apply the conservation of linear momentum, I can say that its mass 10 grams into its velocity is 100. Yes or no? So mass into velocity is equals to, so this one after collision. So it is initially at rest plus 0. Initially it is at rest before collision. So now after collision, so they both move together. So 10 plus 10, this is 10 grams and this is 10 grams. They both move together. So with some common velocity v, So what is that common velocity we are finding now? So what is that common velocity v? So which is 1000 is equals to, so 20 into v. So from here v is equals to, so 0 cancel, 50. So this is 50 centimeter per second. So convert it to meters. So I can write 0.5 meter per second. Yes or no? So we got 0.5 meter per second. So now can we find to what height it raises? Even if you instead of remembering the formula, you can just follow the simple procedure, the conservation of linear momentum here. The first one is conservation of momentum. The conservation of momentum. Clear guys? Chalo. So now, so the h is equals to v square. V means 0.5. I can write 1 by 2 into 1 by 2 by 2 into, let's take g value as 10. They said in the question 10. So h is equals to, this is 4 into 20. So which is 1 by 80 meters. So 1 by options they gave it in centimeters. So let's write it in centimeters. H is equals to 1 by 80 into 100. So from here 0 cancel, 2 5s are, 2 4s are. So 5 by 4 means 1.25. So 1.25 centimeters. So to what height it raises? 1.25 centimeters. Option 4 is the correct one. Clear guys? Understood the concept? Chalo. So let's move further. So now, so we have already discussed about the coefficient of restitution, right? So what's the coefficient of restitution? It's a relative velocity of separation by relative velocity of approach. So in the previous session, so we have seen, so if it is a mass m1 which is moving with u1 velocity, if it is a mass m2 which is moving with some u2 velocity, after collision m1 moves with v1 velocity and m2 moves with v2 velocity. So if it is a perfectly elastic, if it is a collision takes place, so then we have seen that the relative velocity of approach is equals to the relative velocity of separation. Yes or no? So now the coefficient of restitution E is equals to, we can write relative velocity of separation, which is v2 minus v1 by relative velocity of approach, which is u1 minus u2. Relative velocity of separation by the relative velocity of approach. Okay, so if this relative velocity of, if this coefficient of restitution E value, if it is equals to 1, so then it is said to be perfectly elastic collision. If it is perfectly elastic collision, so then E will be equals to 1. If E is equals to 1, so the relative velocity of separation is equals to relative velocity of approach. 1 into U1 minus U2 is U1 minus U2 is equals to V2 minus V1. It will be, right? So if E is equals to 0, so then it is said to be the perfectly inelastic collision. Perfectly inelastic collision. Okay, so if E is between 0 and 1, if E is between 0 and 1, so it's partially elastic or inelastic. It's partially elastic or inelastic. Clear? Understanding the concept, guys? Chalo. So this is about the coefficient of restitution. Now, so let's see the questions. As I said earlier, partially elastic or inelastic. So the E will be between 0 and 1. So if the E is between 0 and 1, so it's partially elastic or inelastic. Partially elastic or inelastic. Done? Chalo. So let's move further. So let's move for the question. So here, what's the question says? A ball moving with velocity 2 meters per second collides head on with another stationary ball of double the mass. See here, the first ball is moving with a velocity 2 meters per second. So, and another mass which is double the first one, which is at rest. So the collision happened. So then if the coefficient of restitution is 0.5, so which means, so it's not completely elastic or not completely inelastic. If E is equals to 1, completely elastic, perfectly elastic. So if E is equals to 0, perfectly inelastic. So it's partially elastic or inelastic, right? So then their velocities after the collision. So let's suppose the M block moves with a velocity V1 after the collision, and 2M block moves with some velocity V2 after the collision. Let's consider this. So now, first if it is the collision, so whether it's partially elastic or partially inelastic, so we can simply apply the conservation of momentum. The first thing is apply the conservation of momentum. So if you apply the conservation of momentum, so we can write its mass is M into its velocity is 2. So and second one, 2M into its velocity 0, it is at rest. And finally M into V1 plus 2M into V2. So I can write here 2M is equals to, this is 0. So MV1 plus 2MV2. So we can cancel M. So here V1 plus 2V2 is equals to 2. So let it be equation number 1. So then, so another equation that you can make when the coefficient of restitution value is given, so you consider E formula. E is equals to the relative velocity of separation by relative velocity of approach, V2 minus V1 by U1 minus U2. So from here, what is the E value? 0.5, which is 1 by 2 is equals to V2 minus V1, let it be U1 minus U2. So the initial velocity of the first one is 2 minus the second one 0. So 2 minus 0 means 2, 2 gets cancelled. I can write V2 minus V1 is equals to 1 here, right? So this is a equation number 2. So now let's add 1 plus 2. So let's add these two equations. So let's add equation 1 plus equation 2. So what do we get? V1 plus 2V2 is equals to 2, and then V2 minus V1 is equals to 1. So from here V1 cancel, 3V2 is equals to 3. From here V2 is equals to 1. So if V2 is equals to 1, substitute V2 is equals to 1 here. So 1 minus V1 is equals to 1. So if you send 1 minus 1 to that side, so V1 will be equals to 0. So the yes or no? So V2, if you substitute 1, so 2 minus 2, 0. Yeah. So the first one, V1 0, V2 1. V1 0, V2 1. So option 1 is the correct answer, guys. Clear? Chalo. So let's go further. So the question number 16. So which was asked in NEET 2018. What's the question says? A moving block having mass m collides with another stationary block having mass 4m. So this is a moving block. So let's suppose it's moving with 4m, sorry, velocity v. So collides with another stationary block, so which is of mass 4m, so which is actually at rest. Fine. So the lighter block comes to rest after the collision. So the lighter block comes to rest after the collision. So when the initial velocity of the lighter block is v, so then the value of coefficient of restitution in this case, so this is a 4m block, let's suppose it moves with some velocity u. So we have to find what is the coefficient of restitution. See here. So the first thing is apply the conservation of momentum. So here its mass into velocity, initial velocity, is equals to 4m into, so this is at rest, so I can write 4m into 0. So and after collision, so this comes to at rest, so m into 0, and then 4m mass moves 4m into, let's suppose its velocity u. So then shall I write here mv is equals to 4mu, mv is equals to 4mu. So here mass gets cancelled, so v is equals to 4u. So v is equals to 4u. Fine, let it be. So then let's come to the coefficient of restitution formula now. So what's the coefficient of restitution formula? The relative velocity of separation, v2 minus v1 by u1 minus u2. So here E is equals to final velocity, u2 means v2 means u, right? So after collision, this, yes or no, this is v1, this is v2, v2 is equals to u, we considered u, right? So we got the u value, and then v1 is equals to, it comes to rest after the collision, so v1 0. Then initially u1, so what is u1? u1 is v minus, so 4m, the second one is at rest, so here it's u2 is equals to 0, and then u1 is equals to v we considered. So then E is equals to u by v. So did we get what is the u value? So or else you substitute here u by, so in place of v you substitute 4u. So u cancel, the coefficient of restitution is 1 by 4. 1 by 4 means I can write 0.25 guys. So the coefficient of restitution is 0.25. Clear? Understood everyone? Chalo. So let's move further. So then the rebounding of ball after collision with the ground. So let's understand this concept. So first let me consider, here is the ground. Here is the ground. So there is a ball which is of mass m. So it is free fall, falling freely from here. Okay. So then, so by the, just before reaching the ground, let's suppose its velocity is u. Okay. So if the collision is inelastic, so I'm saying the collision is not perfectly elastic, so then it loses some energy, right? When you drop a ball, so it touches the ground, it collides with the ground, and after that it rebounds. But just before it touching the ground, it has, let's suppose, some velocity u. So then after rebounding, it will have some other velocity v. After rebounding, it will have some other velocity v. So because after collision with the ground, so some energy loss takes place. After collision with the ground, so I can say energy loss takes place. Energy loss takes place. So understand this carefully. So energy loss takes place. Now listen. So I am considering, let's suppose, so this is a body 1, and then consider the ground as body 2. So consider this as body 1 and then ground as body 2. So now let's apply the coefficient of restitution formula. You know that the coefficient of restitution is equals to, so the relative velocity of separation by the relative velocity of approach, v2 minus v1 by u1 minus u2. So see here, so v2, what is v2? So the second, what does it mean by second? So the second we consider the ground. So the first we consider the ball. So what is the ground velocity after the collision? Ground will be always rest. So the ground velocity after the collision 0. So then, so ball velocity after the collision I considered v. Yes or no? So the ball velocity after the collision. V2 means the velocity of the second body after collision. V1 means velocity of the first body after collision. So the first body is what? Ball. The second body, ground. So the ground velocity after collision, 0. So the ball velocity after collision, V by. So then initial U1, initial velocity of the ball. What is the initial velocity of the ball? So initial velocity of the ball is U. It is just before hitting the ground. With what velocity it is hitting? U velocity. And then, so what is the U2? So ground velocity 0. Yes or no? So the ground velocity 0. So then I can write, so E is equals to, so V by U. So just don't consider the sign. So we can write V is equals to EU. V is equals to EU. So V2 minus V1 by U1 minus U2. So the body's velocity, see, you can consider here it is minus U. Why? Because it is coming down, right? So to cancel it, so we can consider minus U because it's coming down. So with what velocity it's coming down? With minus U velocity. So then you can minus U minus 0. So then minus cancel. So we got V is equals to EU. V is equals to EU. So this part is clear, guys. Understood? Chalo. So next, let me write the next part. Sorry. So this is a ground. Again, the same concept I am explaining. So this is the ground. First, the ball is dropped from here. So the ball is the first body. Okay, ground is the second one. So now the ball hits the ground with some velocity U, and then it bounces back with some velocity V. Okay, so then let's suppose its height is h. Consider originally its height is h. Okay, after collision, so it raises to some height h1. Why? Because it's some energy loss takes place in the collision. Some energy loss takes place in this collision. So that's why it raises to some height h1. So now you know that a freely falling body will have the velocity before touching the ground. So its final velocity will be √2gh. And then we got the relation, the coefficient of restitution form, as per coefficient of restitution formula we got. So with what velocity it rebounds, V is equals to EU. So from here V is equals to E into what is U? √2gh. So now my question is, to what height it rebounds? To what height it rebounds? So it rebounds to a height of h1. So it rebounds to a height of h1. So which means, so what is the h1? h1 is equals to, the rebounding height is v square by 2g. This formula we already know. So what is v? V is E into √2gh whole square by 2g. From here I can write E square into 2gh by 2g. So 2g cancel. So this is E square into 2h. So this is to the height h1 it rebounds. Now, so this ball, so we did not disturb it. So that means once you just dropped it, so it touched the ground and it again raised to some other height. Let's suppose you dropped from this height initially. Okay, so you just dropped. So then it hits the ground and comes back, so to some other height. So you dropped from here and it reached this height h1 here, because there is some loss in energy. Now again you did not catch this one, so again it collided with the ground. So now let me take the third scenario. So and again, so it's going with the velocity v, and again it comes down with the velocity v. So again it comes down with the velocity v. So after collision with the ground, so it rebounds with velocity v dash, some other velocity v dash. Why? Because its energy loss takes place here also in this collision. In the first collision some energy loss takes place. So with u velocity it strikes the ground, and with v velocity it rebounds. Now with v velocity it's striking the ground, so with some other velocity v dash it rebounds, right? So therefore what is this v dash? So this v dash will be equals to, you can write v into e, or else you can write e into v. See here, if it is striking the ground with a velocity u, so and rebounding with a velocity v, so what's v is equals to e into u. So it's with what velocity it is striking the ground into coefficient of restitution. So now in the next scenario, so it's striking the ground with velocity v, okay, and rebounding with velocity v dash. So then what will be the relation between these two? So v dash will be equals to, so e into u. So then v dash is equals to e into, so what we can write in place of v is equals to e into root 2 gh, right? E into root 2 gh, right? So then v dash is equals to e square root 2 gh. Just understand the concept, v square into root 2 gh. So now obviously it will not raise to the same height as of h1, so it will raise to some other height h2 this time. It will raise to some other height h2. So now how do you find h2? So the h2 height will be equals to, with what velocity it is bouncing? V dash velocity. So that velocity square by 2g. So what is v dash velocity we got? E square root 2gh whole square by 2g. So from here e square means this comes out to be e to the power 4. So 2g gets cancelled. So h root h means h. So that means h2 is equals to e to the power 4 h. So that means in the second rebound it raised to a height of e to the power 4 into h. In the first rebound it raised to a height of e square into 2h. So now similarly in the h rebound, sorry. So let's suppose, so in the first rebound, again let me draw the diagram. So let me make the concept clear for you. So first here you are dropping from here. So here it's hitting the ground with u velocity. Then it it's rebounding with velocity v. So what's the relation between these two? V is equals to e into u. So then let's suppose it raised to some height. Initially it is at a height h. Yes or no? So then it raised to a height h1. So what is the h1 height we got? h1 is equals to e to the power 2 into h. Yes or no? So the first one e to the power e square into h, right? So then again, so it's coming back and hitting the ground with velocity v. So it's coming back and hitting the ground with velocity v, and again it rebounds with a velocity v dash. So you know that v dash is equals to v into e into v, right? V dash is equals to e into v is nothing but, so what is v? V is nothing but e into root 2 gh. Yes or no? So v is nothing but e into root 2 gh. So then this is v dash. So now height h2 will become v dash square by 2g. So from there we got h2 height as, so e to the power 4 into h, right? So then again, so it goes up and raises to a height h2 here, raises to a height h2. So then it comes back with a velocity v dash. Now it comes back with a velocity v dash. Now it again rebounds with some other velocity v double dash. So then it raises to some other height h3. So then v double dash is equals to e into v dash, e into v dash. So what is e into what is v dash? V dash is e into root 2 gh. Yes or no? E into root 2 gh, which becomes e to the power 3 into root 2 gh. So then height will become what? So height h3 will become e to the power 6. Square means e to the power 6 into 2g cancel, e to the power h. Understanding, guys? So first height e to the e square into h, second e to the power 4 into h, third e to the power 6 into h, where e is the coefficient of restitution here. So now after n rebounds, it raises to a height, the height after n rebounds, it raises to a height of, so the general formula we can write e into 2 to the power, e into 2 to the power n into h. E into 2 to the power n into h. So in the first rebound, in place of n you can substitute 1, so that e to e square into h. So in the second rebound, e to the power 2 into 2, so e to the power 4 into h. So in the third rebound, e to the power 2 into 3, e to the power 6 into h. Clear, guys? So this is after n rebounds. So this is the concept, that's it. Clear? Chalo. So let's move further. So what's the question says here? A ball dropped on the ground from a height h, if the coefficient of restitution is e, velocity of the ball after the collision, see. So it is dropped from the height h. So then its velocity v will be obviously e into root 2 gh, right? It is dropped from the height h. So its velocity will be is equals to v into So with from what height it is getting dropped? H height. So V is equals to E into root 2GH directly. Option 1 is the correct answer. So next question. A ball is dropped on the ground from a height h. If the coefficient of restitution is E, then what will be the rise, to what height it will rise after jumping twice? So jumping twice means n is equals to 2. So just so the rebounds after, to what height it rebounds after n rebounds is equals to e to the power 2n into h. So e to the power 2 into, so after 2 rebounds they are asking, twice means 2 rebounds, so into h, so which is e to the power 4 into h. So the simple question, e to the power 4 into h, after option 4 is the correct answer. Clear? Hope you have understood the today's lecture. So with this we have completed the system of particles and the center of mass. So the collisions concept is important for your competitive examination, guys. So and it's an easy topic also. We have solved n number of questions. So alone in today's session only I have solved some 18 questions, I guess, right? Yeah, so I have solved some 18 questions, right? So you just practice some more questions just to analyze your understanding levels. So whether you are able to apply the concept or not. So you can check by taking some practice sheet related to this concept. Okay, understood, guys? So in the next class I am going to start the new chapter, that is rotational motion. So where I am going to allot some 8 lectures for the rotational motion. We'll discuss in detail step by step. Okay, so from basics to advanced. So till then, keep studying. All the very best. Bye. Take care.